Good afternoon, everybody. Thanks for attending my session at the Couchbase Connect. My name is Feng. I'm from eBay. Today, we're going to talk about how the eBay uses NoSQL, particularly in the last couple of years, how we utilize Couchbase to power the lot of mission-critical application across the whole eBay marketplace. A few things about myself. I have been working on the database area all my professional career. First 15 years on Oracle. Basically, I started Oracle about version 5. I got about 10, 20 floppy disks, and also in the beginning, take a while to figure out Scott Tagger username password. After I start, when I use the Oracle Microsoft SQL Server, I work with DoubleClick, Yahoo, Intuit. That's my RDMS career. I joined the eBay about 2011. After that, I solely focused on the NoSQL. I'll start with Cassandra, Mongo. Last couple of years, we're focused on the Couchbase a lot. So I'm part of eBay database infrastructure team. We're handling all the eBay's database, include Oracle, MySQL, Cassandra, MongoDB, and the Couchbase. We're handling all the company-wide NoSQL projects. I speak a couple of times at the Cassandra Summit, also the Enterprise Data World 2016, also the NoCalc 2016. Also, I've been rewarded a couple of times on the DataStack MVP. Talk about eBay a little bit. eBay used to as auction site, but now actually a majority of the eBay's revenue are coming from the fixed price listing as well. Just like you buy from other e-commerce site, now you can buy directly, you can buy it now from eBay as well. At any given time, we have about 1.1 billion active item listing on eBay for sale. And we have about 164 million monthly active users visiting eBay. And also we roughly about 8 to 10 million sellers. We have a huge database infrastructure to support the eBay websites. Roughly, we have about 4,000 plus database servers. And every day, those servers are making 610 billion SQL calls every day on daily basis. And we can see peak database call is about 15 million database call per second. And among them, majority currently is about roughly 80% is coming from RDBMS, primary Oracle plus MySQL, and the rest 110 billion coming from the NoSQL, and the majority of also NoSQL coming from Couchbase. Year over year, we see that database traffic grows at about 35%. So definitely eBay is a big database user. Traditionally, since eBay started about more than 20 years ago, we have been a very heavy Oracle user. eBay itself is about almost the largest, almost the largest Oracle deployment over the world. So it powers all the critical function, all the user, item, transaction, fraud, everything into the Oracle database. However, over the years, we also found there's a lot of challenges just using the Oracle to support the eBay infrastructure. So first example, eBay, Oracle maintains those ACID features. Relatively, it's very expensive. However, if you look at all the eBay use cases, some of them doesn't need those features. That means we implement this feature on the Oracle, so we have to take the performance penalty, right? And even we don't have to. Also, we have Oracle itself, lack of native shardings, and also some replication feature, the native one. So eBay actually did an amazing job in the Oracle infrastructure. So we don't use the rack. However, we build a logical database concept, which we do the application level sharding. So theoretically, we can scale Oracle database horizontally across. So we can do a model-based. For example, we can do a model 10, model 12. We split a logical database into a 10 or 12 physical Oracle database. We also can do range-based database splitting, for example, for the atoms. Also, we can do the lookup-based database splitting, for example, like a user database. So we built this database splitting infrastructure back in early 2003 or 2002, something like that. This is a very well-designed architecture. It has been running well for past 10 plus years, and also going forward, it still can do. Even with those features, we use a lot of like SharePlex to transfer data between oracles, and also we do the Golden Gate, and also we do a lot of Active Data Guard recently. However, Oracle, another disadvantage is it's very expensive on the license support as well as the hardware, right? Not just you have to use the proprietary hardware like Sun or the Sun machines, which we're using for Oracle. Although also we have used a very high-end Hitachi disk storage arrays. It's also very expensive. So overall, if you think about the average cost for every single commit to the Oracle database is very expensive. So we have to think of something outside Oracle. So if you look at on the market, there are so many, used to be hundreds, maybe now it's thousands NoSQL database, right? Everybody, they have their own unique feature. They try to solve a particular problem. So if the chart listed, right, as you can look at the chart, based on the scalability or based on the complexity, there's several typical, like a key value store. We have a column family, a document database, a graph database. So at eBay, we have used many of them. And we're using Redis for key value stores. We're using Cassandra. We use MongoDB. We're using also Couchbase as a combination of the key value store and the document database. And also we're using Neo4j to serve as a graph database as well. So among those 100 databases, NoSQL database, how do we evaluate? How do we know when to use NoSQL, when to not use NoSQL, and also which NoSQL to use? So we have to do a lot of evaluation in the beginning over the time, and also whenever there's a new feature coming in, we have to evaluate. So we summarize a lot of our learning and our understanding of the NoSQL. So here are some of the benefits we can get, right? So compared to the traditional Oracle, MySQL, etc. So we get a distributed replication and sharding. That's almost building every single NoSQL product. Also, we can do a location-aware local query. So that's definitely going to avoid cross data center latencies. Also, we can customize, design the NoSQL database or either data infrastructure, data model per the flexible enough to meet your workload or access patterns. And also, a lot of them provide a very linear scalability, like a Couchbase, like a Cassandra. And also, during this horizontal scale, it will almost without any interruption to your business. And also, it also supports those semi-structured and even unstructured data, which is not very useful in the RDMS world. Another big point for the developer is a flexible schema, right? You don't have to wait for DBA to make a column addition before you actually use it. With all those pros, also we found some restriction, right? So none of them provide strict ACID compliance, so it's hard for you to implement transaction-based use case, particularly for anything related to the financial money, etc. Also, you get the flexibility of the schema. However, you lose you don't have a strong control of the data modeling, right? Potentially, application can write a totally different, data component, which could mess up your whole use cases. And another thing is, most of the cases that you design your system to meet a few access pattern, you do that. If you are trying to do something different, the performance may not give you you may not see the performance that you are expecting. And coming from the traditional RDMS world, if you go to the NoSQL, you have to totally think about something differently. So that's not only from the DBA point of view, but also from the developer. You have to change your mindset, and also you have to deal with how do you write your application in the distributed environment. As I said, there are hundreds or even 1,000 NoSQL products there, and everybody is evolving very fast. So every about 6 months, we're going to see a product new release coming in with a new feature, with a bug fix, with a performance improvement. So we have to be work intelligently to pick the product, stick with it, and also grow with it. Okay, here is the after those evaluation stuff. So we pick a few major ones. So it's just based on the history. We start with MongoDB as a document store. So it's because it has the rich JSON format. It have a very good, secondary. Every developer likes, the JSON format and also those flexible schema. And also, we can scale out reads very easily by adding more sleeves. Especially after Mongo 3x, we can do more than 12 replica set numbers, so you can scale reads more easily. And with Mongo sharding or application sharding, we can also scale writes as well. The problem with Mongo is, when you do the primary reelection, have node failure or intentionally step down some members, primaries, there is a short interruption to your writes. Used to be 20, roughly up to 20 seconds, but in the 3.4 release, I think they're reducing to the single digits. However, you have still deal with those missing writes, and otherwise you're going to lose your data. Potentially, also, one of the big problems for us is when we have the multi-tenant databases, it's hard for you to do a resource isolation. I cannot tell, this, for example, this database using 2/3 of resources, other one using 1/3, which is not possible in the Mongo world. Another one, we use second NoSQL product using eBay is the Cassandra, right? Peer-to-peer without a single point of failure. Active-active, we can read write from both data center, and data will be synced to other one synchronously. And also, you can get a high read performance as long as you do the primary key lookup. And also, the write is because we do the peer-to-peer, the data will be write to every single other node. The overall throughput will be much better. So you can scale both read and write linearly by adding more nodes to the Cassandra ring. The problem that we are facing Cassandra is secondary index. Even currently, there basically is a kind of a local index. So when you're trying to do those range scan, mostly you have to do the gathering, which is very inefficient. You are not expecting low latency from those kind of range scans. And also, it's hard for you to mix user query and access pattern. So if you want to actually use some indexes, we have to build another column family with different primary keys. Compression overhead is a big killer because Cassandra does append only writes. So you have to do the compaction periodically to eliminate all the tombstone and merge, insert, update together. Another bad thing we've learned from Cassandra is, the writing in Java, JVM, garbage collection is a very killer to us. So in the most recent tuning, we have to upgrade to the G1GC, which at least gives us some breathing room. Same thing is like Mongo, it doesn't have a resource isolation. And also, when we're trying to add or remove nodes to the Cassandra, the data streaming is very slow, and we cannot, based on your capacity headroom, most of the time we cannot add or remove multi-nodes at the same time. Here comes the Couchbase, which is we started adopting a couple of years ago, and also we see dramatic growth compared to other two. So first things, Couchbase mostly used for the caching, and also whoever knows memcached is get familiar with Couchbase immediately. It's fully compatible, and also it also gives you a peer-to-peer. We can scale read and write. Not only you get the performance, but also you can improve your, increase your throughput by the linear horizontal scale. This one, another good thing is, we get a resource isolation, right? We can assign different memory quota to the different bucket, and also even we can adjust disk priority, I/O priority. So also we can do the active cluster replication. So we can rewrite multi-data center at the same time, and the data will be synced to the other data center very quickly, because in the 3.0, all the XDCR is a memory to memory. Okay, so a few issues we found with using the Couchbase, right? Same thing when we do the node failover. As when we enable the auto failover, there is a grace period. As which I think the minimum right now is 30 seconds, and we have to increase about 120 seconds for eBay environment, trying to minimize the node failover, because every time we have failover, the rebalance, it takes quite a long time if we have a data node with a lot of data. We also have potential issue with the across data center conflict resolution, right? Previously, the conflict resolution is a little bit hard to predict. In the new coming 4.6 release, the last right wins makes things very simple, right? So it's easy, you can, based on the timestamp, you know who is supposed to be the winner when there is a conflict. A few other issues we can talk about a little bit detail in the later is when we do the rebalancing. If you have a large data set, those rebalancing take quite a long time. Same thing with the warm-up. So we have seen large nodes with about terabytes data, it takes about hours to warm up, to load all the keys into the memory. Here's what we have at eBay. So besides the Cassandra Couchbase and the Mongo, we also use some of the HBase, Memcached, Neo4j, OpenTXDB, and Redis. Officially, from the company point of view, database infrastructure team, we provide support for the top 3. Here's the footprint, actually the number of nodes we use in the last couple of years. If the top green one is the MongoDB, as you can see, the moderate growth, because it provides you as a document store with a flexible schema, as well as a very useful secondary index. That's the primary reason we see the growth in the MongoDB. The last one is Cassandra. We see relatively flat node increase. However, those nodes is very large. We can have up to 30 terabytes storage attached to each single node. Because at the moment, most of the Cassandra use case is for the like a write intensive logging. We have a huge Cassandra nodes. Whenever we have, for example, have a failed nodes, we're trying to bootstrap. That take quite a long time. But the middle one, the last one, as you can see, the red color, that's where using the Couchbase. We lose a little bit history data when we split with the PayPal a little bit over a year ago. But as you can see, after that, from the roughly in the starting in the Q3 last year to this year, we grew from about 300 nodes to about 1,400. This chart I only showed at the end of September, but also in October alone, we deployed another 200. So currently, we're at about 1,400 nodes. That's about almost 5x growth from a node point of view. From a use case point of view, we more than doubled our use cases. There are a few things we talk about, why we're using Couchbase, because we're using one common use case as caching in front of Oracle. So we basically don't have to add more and more Oracle to support those use cases. And also, it gives us a pretty good scalability and very high read-write performance, and also throughput, which is amazing when we do those benchmark testing in the beginning. This bidirectional SDCR is very useful. Even with all the 3.0 and later, we can do the memory to memory. Because when we start with the 2.5, the SDCR is one of the problems we're having, because the latency across data center replication doesn't really meet the eBay requirement. But after 3.0, memory to memory definitely helps a lot. And also, another thing we like the Couchbase is the new Nico stuff. It definitely is a help with the people coming from the traditional relational database. Here the environment we're using at eBay. So we are support both dedicated. If you have a big use case, you need a lot of data, you need a lot of nodes, we give you a dedicated cluster. So you only have a dedicated single bucket or maybe one other bucket. And also for smaller use cases, if you want bigger fault tolerance, give you a multi-node cluster. It may not be kind of overkill, but we put on your shared cluster. We give you a dedicated bucket. However, single cluster will host multi-buckets. We're running both the Enterprise 3.1 and also we started using the 4.5. In early 2017, we're going to upgrade all the existing 3x cluster to 4.5. We also support both bare metals and also virtual machines. eBay have a private cloud, which is built on OpenStack and also KVM. And we are running all our database infrastructure on the Red Hat 6 and 7. We also support different hardware profile. Based on use cases, we can give you the high I/O, which give you a SAS local SSD, which give you a very low disk access latency. We can also give you a very high memory, up to right now is between 60 GB to 512 GB. And the next year, we're going to probably starting evaluate using the 1 terabyte memory the physical host. We also have the high storage flavor. We can attach 2 terabytes up to 8 terabytes with local SSDs. We also build wrap all the original RPM from the Couchbase. We customize a little bit for the eBay environment because we have our own log collection. We have a metric reporting. We do the same thing for the driver. So that's also we manage a central we call it data access layer. So that increases a lot of error detection, logging, and reporting as well. So we do this from both client side as well as the server side. So as a big enterprise, we have a dev environment, we have a QA, load and performance, pre-production, production environment. So whenever you release something, both software and server software and also client application, we basically go through a pretty full test cycle before we end up in the production environment. Just few steps when we do the onboarding process. Right. First thing is, when we do the onboarding, we have to understand the product, right? Whether we can support this feature. For example, 3.0, you cannot do the NoSQL, right? And if you don't use the data index, query nodes, you also cannot use NoSQL, all the stuff. And also, we have to evaluate your business requirement. Is this a good NoSQL use case? Is this good for the Couchbase? So there is a review process with the developer, DBA, as well as the data architect. We also do a lot of, there is a workflow based on your requirement, we can recommend one of the NoSQL database, and with a lot of details which we're trying to collect at the beginning. After that, we'll do the data modeling. So even you have a flexible data schema, we still need the PD developer and the data architect work together to design a system. So you have to understand what's the good use case, what's the not good use case to use NoSQL. And also we do the POC testing and the LNP testing. And also we have a dedicated capacity planning team. And also we work with the Couchbase consultant to do the initial setting. And also periodically, we still need to reevaluate based on the extra usage. And we look at, do we need to add additional capacity, or either we can shrink? Because in the beginning, it's hard to project how much, what the exact usage should be. Sometimes you overestimate, sometimes you are underestimate. Here's some detail about how we are using Couchbase eBay. So we have the number a little bit different. So total server number actually is not 2,000, it's 1,400. So we have about 120 clusters. We deployed cluster mostly always 3 data center. So we have a roughly 40 different, the global clusters, if you think of that wise. We're doing about 80 million. So if you remember in the beginning, eBay-wise, we have 110 billion NoSQL calls. Out of them, 80 billion are coming from the Couchbase. So you can see how heavy we're using Couchbase at eBay. So year-over-year growth from the use case point of view, 100%, and also from the number of nodes, we have about 5x growth in the last 12 months. We have 90 terabytes data on the Couchbase. That's from about 60 billion documents. For the busiest cluster, for the writes, we get about, at peak time, we get 800,000 writes sets per second. For really intensive use case, we have about 1.2 million gets per second. I want to give you talk about a few use cases. So we support all the three, right? We have a write-intensive use case. One of the examples we call it a user session tracking. So roughly we get 13 billion writes on a daily basis. This is one of the write-intensive. Second category is a read-intensive. It's an email notification. So if you are an eBay user, you may aware, you get a lot, some of the eBay emails, some of the marketing email, something related to your activity. For example, if you bid on something, you get update your overbid or your bid closed. Or you also, same thing, you get if you watch item, etc. So those emails coming from also powered by the Couchbase. We get about 4 billion reads for this particular email notification cluster. We also support mixed workload. So eBay, we have hundreds of thousands of devices, right? So those devices, have to be monitored at real time. So if something happened, we have to react quickly before it causes, sad impact. So we built this whole eBay infrastructure. We can show the graph a little bit later solely on top of the Couchbase. So in this cluster, we get 2 billion writes. So a lot of things that we get almost a few seconds, we refresh the status, on the device level. And we also get about 10 billion reads per day for this central read-write intensive use cases. Here's one example. So it's for the we call the global user preference. So we have a Couchbase cluster. We stored all the users' preference about seller advertising, member communication, user account setting, etc. So this is a kind of a caching in front of the data warehouse. So all the eBay's user activity data eventually goes to Hadoop, also goes to Teradata. So they do a lot of the data massaging from Teradata, and also they're trying to use this personalized data to improve user experience. So if you're trying to query the data warehouse in real time during the user transaction, which is also impossible. So we pull those data periodically from the data warehouse. The data actually will be accessed when the user visits the eBay site in the real time. So Couchbase right now is serving a high performance cache, which is, we can meet the user performance requirement. And we have basically, this is the kind of a graph which is the direction we want to go. We want to distribute the data across the world in the multi-continent. For currently, we have a multi-data center in the US only. So, but in the next year or two, we're trying to push the data close to user as much as we can. We're going to start deploy, basically open data center worldwide and put the data close to the user. This is a central monitoring alerting system we're talking about. So this is basically a pop-up model. So it collects hundreds of thousands of devices that include the server, storage array, network device, switches, load balancer, etc. So all these pieces of the hardware had to be monitored. Also include the software application level. We call it also software pools. All these components have to be measured, evaluated at real time to see whether healthy or not. Do we need to add additional capacity to meet on-demand requirement. All this can be done real time. So without a high-performance data store to solve the problem, we potentially could lose the time to react to increased demand or either failed hardware. So all these things is totally built on Couchbase. So it's a very special thing about this Couchbase database. So this database data set alone is pretty small, right? If you think about only 100,000 devices, that's not much data. So the total data set is about 10 GB only. However, the transaction rate for this one is very high. The previous slide, the one showed with the 2 billion writes, and also those data have very short TTL. Some of them even just a few minutes. So basically, you see this is the data, small data set have a very high change rate. So this is a very unique, it also have the unique problem. Just currently, a couple of weeks ago, we found that one of the problems is we're using views on this cluster, which is still on the 3.16. So we hit one of the bugs, which is fixed 4 months later. Since we are, eBay, because of holiday season coming, we have a moratorium, which we cannot make major changes. So we asked Couchbase, which provided the backport bug patch to us, probably in just a few days. Right now, we're roll out the changes, to solve the problem. That's because with the high change rate, the view compression and also indexing refreshment cannot catch up, just because of the high transaction rate. Since also this is a critical cluster, so we did something special treatment, right? Normally the cluster, we have a 3 data center deployment, and they're active, receive the read and write. For this one, because this is the most important cluster in the eBay, so we build a 2-set cluster. We call it A and B, active and inactive. So when we do the patching, when we do the upgrading, when we do something other testing, we flip between A and B. So this is on demand. That gives us, the best guarantee. We don't want the system to get interrupted, and also we normally keep this running at 2 different versions. Even we face a little bit, one of the bug in one release, we can simply fall back to the previous stable release. So that gives us additional guarantee to provide, always available high performance data store. That's coming from the Couchbase. It's very, useful to us. Another thing is pretty simple about scalability. In my previous speech at a different conference, I always trying to point out is because in people's mind, when you think about the NoSQL scalability, always people think about scale out, right? Whenever I see a problem, I add nodes. Regardless, you are short of I/O capacity or memory or CPU, I just keep adding nodes. However, most people maybe overlook something, just a data center footprint, right? When you add a server, those servers will be occupied on a rack in a data center. You still need to pay the space, power, cooling. All this end up with money. So at the eBay scale, we cannot just simply throw the server trying to solve the problem, because when you just simply add the server, you are wasting some of the resources. So we have to look carefully to evaluate what was short, right? When you look at capacity, do we need more memory, faster CPU, faster disk, or something else, or even sometimes network throughput. So that gives us 2 options, right? Sometimes we need to scale up. However, that's the limit, right? As with the commodity hardware, you could reach the ceiling pretty soon. For example, we cannot go beyond 512 GB memory per node at the moment, unless next year we go to 1 terabyte. And so we have to look at case by case. That's one thing we learned pretty hard last year. Last 2 slides, we want to go through very quick learning experience. So because of the failover grace period, we lack of always available writes. So we do have a workaround within the application. So application can make a decision if they get a write field exception, they can option to write a remote data center. Even you get extra latency, however, that guarantee you don't lose as a single writes. We also have those update conflict, which is in the 4.6, this all last write wins. That's very simple. We also see metadata memory overhead because if you have a small key, additional 56 bytes metadata is a kind of a killer for you. For example, sometimes we have about 8 bytes, so 56 bytes additional is 7x. Basically, you are using 12.5% of your memory for your own key. Others is used by metadata. We also see another problem for the memory fragmentation with the 3.x. So because the memory allocation process library is different in 3x and 4x. So in order for you to solve the problem, bouncing the Couchbase alone is not to solve the problem. We have tried that, but soon after, very quickly, we're going to end up with the same problem. So that's why when you provision a machine, you have to be careful set up the memory quota, because you have to leave more than enough to make sure you don't hit this memory fragmentation. Otherwise, your memory cache process mostly will be OS being killed when it runs out of memory. The other one is the slow rebalancing because large data set, so that's why most of the cases we're trying to use the swap rebalance between 1-to-1, that'll be much faster. Also, warm-up problem. So one trick is as part of the startup process, we modify the script under initd. So basically, we remove the access log. So that's going to make the warm-up much faster. Normally, even read those access log maybe take 10 minutes, even half an hour. So removing that definitely improves. Another thing we find in the QE environment is because we're using shared QE environment, so currently there's a 10 bucket limit. So think about it, we have more than 40 use cases. Just trying to meet this requirement alone, we have a fourth set of clusters. Think about it also, we have to meet at least 2 releases. So that means we need 8 set of clusters just to meet the QA requirement. Last one is talk about what something we like to see in the coming releases. First one is mostly right now we're using as a caching purpose. So the data is coming from a different data store, Oracle, Teradata, even Hadoop, right? So we don't see many of the source record data in there. So that's why we're looking for the point-in-time recovery feature from the Couchbase so we can store the SOR data. We also like to see a global admin console. Currently, you have a console per cluster. It's harder for you to see a global picture, right? So some other product, you have a global one, you can combine the multi-data center together, you can see comparison, do I have an unevenly traffic distribution for same use case, but across different data center? But here is with the current release, you can, but hopefully we can get a global one, which you can see multi-data center at the same page. We also like to see if we can reduce the metadata, which we just talked earlier. 56 bytes is definitely too much for smaller key size. We also like to see rebalancing become more robust. We have keep seeing rebalance failed because of some of the network flip, or sometimes you don't get handshake if the cluster was busy. So if the current situation, we have to manually click rebalance button. But going forward, we like to, Couchbase can have a built-in for torrent. We also like to see, lazy warm-up. Instead of you load data, everything before you put it back to the cluster, if possible, we like to see just load the minimal data set, and when you get and join the cluster, then you start to load the data when the user starting access the point. And also, if you're using the Couchbase, you know how difficult it is to tune those XDCR. There's so many things, you can see from an admin console. There's so many things you can do, from the command line, right? And same thing with the XDCR and also the compaction. So we like to have a simplified, right? Maybe with a different profile. See, I have a heavy writing time use case. What's the typical XDCR setting? So instead of you tune different dial yourself, we rather have a predefined setting with use. Another big thing, if you trying to troubleshooting something in the Couchbase, right? If you go to log directory, there's so many logs, more than 10 type of logs. You have to go through all of them if you're trying to troubleshoot some problem. we have talked about Couchbase a lot. When can we combine them in a single log, right? You don't have to look through so many logs and find the problem. So this is all about my today's session. So we just go over how we're using the NoSQL, particularly Couchbase, in the last few years at eBay. We also shared our, some of the learning experience and some what we're, looking for from the Couchbase in the coming releases. So, any question? So eBay also, we have only limited number of resources managing, thousands, all combined NoSQL. We have more than 3,000 database with only five NoSQL DBs, distributed between US and China. So we also keep looking for, experienced NoSQL professionals. So if you are interested to work at eBay, you can send a resume to my email address at the bottom. Sure, please. Oh, capacity planning. So if you, we start work with the data stack consultant. So the question is, how do we do the capacity planning? So we work data stack consultant, right? They have a kind of a setting Excel. So we collect information from a developer. Actually, I can share one of the setting we did early. So we need to collect some basic information, then we calculate all the setting from here. Okay. So if you look here, so this session is basically the data input we're looking. Oh, how do I see it? Okay, let me stop sharing. Okay, now. Okay, so if you look at on your left-hand side, right? So when we do the capacity sizing, we have to get some information. That's critical ones, how big is your key, right? How many bytes? That's a primary factor to calculate the memory requirement. We also need to know what's your average value size, right? In this case, it's 800 bytes. We also, how many replica we wanted. So by default, we keep one primary, one replica. So at least when the one node fails, you still can have a local node access. Then we look at we need to know also what kind of hardware, how many memory on each node we can support. And also you need to tell us how many keys total you want to save in the Couchbase, and what's your working set, basically the hot data set, how much data you would like to save in the memory. We also need to know number of transactions, right? Read, write, delete, and also we need to know the type of the storage we're using. So the output here is based on the calculation that's a very complex formula on the other side. So you end up with okay, if you are memory bound, right? We need based on the 96 GB nodes, so we need 14 GBs. If you are I/O bound, you just need 3 nodes. So that's what we are with doing the capacity. So we do the initial sizing ourselves internally based on the data collected from the developer on the use cases. Then we review with the Couchbase solution architect. So that gives us, some of the confidence when we starting deploy the new use case, we're going to at least all the number is about cover 6 to 12 months. So that's the initial, but however, we still need to do the periodic capacity review and to decide that we should put more hardware into the cluster or not.
So about the traffic bursting, low speed and high speed, even within the same day, peak time, off peak time, these kind of situation.
Yeah, so the number we're asking is on the peak. If you look here, the numbers, these are the peak numbers. The question is how do you handle those peak and daily variations, right? So the number we're getting is all-peak numbers, right? So we basically always prepare the worst cases, right? You may, in the off-peak hour, you may not utilize all the clusters, all the resources, but we are provisioning the cluster enough, you can sustain your peak traffic. Also, on top of that, we add extra headrooms. Okay.
You said one of the advantages of Couchbase was the resource isolation. I wonder if you could describe what is resource isolation?
So for us, it's mostly on the memory side, right? If you look at the Cassandra Mongo use case, right, you can do the multi-tenant, you put a multi-case based multi-column family on the Cassandra, and you put a multi-database or multi-collections on the Mongo, right? However, you cannot tell how do I split the resource, right? I mean, we did some trick before. Either we run multi-MongoD on same server, at least you can split the CPUs, but the memory-wise, you cannot control. On the Couchbase side, you can assign, when you create a bucket, you can see how much memory it can use, as long as you control everything underneath the memory assigned under the server base, right? That gives you the control. You can split memory. So if you want, you can put more memory in the heavily used cases. You can give less memory on smaller buckets. That's what we call resource isolation. It's not perfect, at least from memory side, it's good enough for us. Okay, thank you very much.
Hi. I have one question.
Oh, sure, please.
So do you use multidimensional scaling?
We, on the 4.5, in order to use in the NoSQL, you have to use that. But we have a little bit issue with that is a lot of, if we're trying to use it as a caching services, you want your latency sensitive, right? So the most use case we're serving here, trying to provide end-to-end latency at 5 milliseconds. So if you're trying to split query, index, and the data nodes, the extra network hub between the servers actually is going to increase your latency. So one of the things that we haven't really tested is that we're trying to use in the cover index as much as we can. So at least you're going to save one of the network hub. But that's something when you use the NoSQL, you have to make sure you think of that ahead of time.
And for the index service, do you see any issue with the rebalancing, or every time you add a new index node, do you I heard you need to manually create index again, right? So do you see any issues in there, or?
No, actually we haven't. So we only started with a few. We haven't really have a need to scale the index node yet.
Okay.
So probably, I have to be careful when we go to that situation.
Okay,
Yeah.
thank you.
Sure. Thank you. Thanks, everybody.